Engineered soils, also known as soil cement, are fast becoming known throughout North America as a much stronger and more durable way to stabilize building pads, roadways, airport runways, parking lots, and much more. This process is inexpensive and long-lasting and includes 3 separate and distinct products.
One of them is cement modified soil, and that's just where we're going to use very, very small amounts of Portland cement, typically 2 to 4% cement, just to change the engineering properties of the soils. Sometimes they're too high in clay and they want to hold on to water. We can change their properties where they don't want to hold on to that water anymore.
The second type is cement-treated base, which uses a little more cement, typically 3 to 10%. That bonds the materials together and holds up extremely well in both harsh, wet-dry, and freeze-thaw conditions.
The third item in that engineered soils group is full-depth reclamation. And that's where we take an existing roadway that's a flexible base roadway, one that's either constructed with crushed stone or soil and has a bituminous surface on it.
The existing base and old asphalt are pulverized, and 4 to 6% cement is mixed in to create the new stabilized base. All 3 engineered soils are used in both private and public works. The Port of Seattle is a full-depth reclamation project built over a former landfill.
There was a lot of existing pavement, asphalt pavement on it, so the first step was to pulverize that back into a crushed rock type material, and then the grades were reset to where they wanted them, and we would do our soil stabilizing.
The wet northwest weather altered the amount of water needed for this project.
Normally we'll push a water truck with the machine and inject water through a spray bar into the rotor to get the moisture content. The soils engineers are liking the way this is looking with the moisture content without using a water truck. So we're just using the moisture that's on the ground already because of all that rain.
Seattle's Sound Transit is another public works project that had to deal with a lot of undesirable fill material.
The big chunks that we expose do get hauled away, but the rest of it will stay embedded in the base because what we're building is a solid cement treated base, and on top of that we'll get a course of crushed rock and then the final pavement, so it'll work just fine as a base material.
An even larger public works project in Oregon used cement-treated base on a hillside with an active landslide.
We are constructing a 60 million gallon potable water supply. It's a reservoir for the city of Sheridan.
We are amending the soil. We do that on a number of our projects. The big difference with this one is the physical volume of amendment that we're doing.
The soil is comprised of silts, clay, and basalt boulders.
Given the remote location of the site and the vast quantities of materials needed, the importing of granular crushed rock and other materials just wasn't adequate.
We've got to dig down to sandstone, dig into the sandstone at least 10 feet. In some places we're 70 to 80 feet deep.
We actually have to set up cells away from our fill area, treat the process in the same method where we spread the bulk cement, till it in at 12 inches deep at a certain percentile, load it into our off-road trucks and haul it into place.
Another very unique application of using cement to change the properties of soils is Safeco Field, home of the Seattle Mariners.
That entire playing surface had to be lowered and the soils underneath the playing surface modified and stabilized a little bit so that the rest of the structure could be built on top of it. So when people are sitting at the baseball game watching the Mariners play, they're not aware of the fact that they're actually playing on a cement stabilized field.
Private sites like this lumber mill in Banks, Oregon also benefit from utilizing soil cement.
You have a lot of heavy loads coming in here, log trucks as well as the flatbed trucks hauling the lumber out. We're trying to make them something they can run on that won't break every couple of years, basically.
We come in, we've ground up the existing asphalt, lowered the whole grade by 4 inches. We're going to spread the cement on top of that, mix it in, compact it, roll it, keep it wet, keep it watered, and pave it back in the same day to the 4 inches that we removed.
Because they're recycling existing fill to form the new base, less material has to be hauled in, greatly reducing truck traffic on local roads. which also reduces cost. Everything the owners tried before this process didn't hold up under the heavy loads.
The road you came in on we did last year is not one crack in it, one failure at all.
Just northeast of Portland, construction is beginning on the Columbia Corporate Center using cement-modified soil and mixing 12 inches deep at 5% for the best stabilization.
The big truck you saw in the back there, that's our spreader truck. He offloads from the bulk cement carrier, and then he spreads the cement on the pad or on the area to be treated. And what I'm running is called a stabilizer reclaimer, and it's like a big tiller.
Much of the quality land in this area has already been developed, which leaves a lot of second-rate sites. Modifying them with engineered soil turns them into first-class sites.
It's just proven. I mean, you know, it's an engineered fact, proven fact that it works.
The Coda Ridge housing development will sit high above Camas, Washington and the Columbia River. It's not only one of the worst hillsides this crew has worked on, they're coping with a very rainy season.
A geotech tells us what percentage of cement they need to get the moisture out of the soil or to get their compaction level, because they have to have a certain level of compaction on this soil to pass.
The soil cement process keeps the hill stabilized. It prevents water from seeping in or leaking out, which saves time.
Yeah, it's done. Yeah, one time and it's done.
And then there's the cost savings.
You look at the price of rock per ton. If they couldn't do this to the dirt, they'd have to import rock. And this allows the contractors to use existing soils to where it saves them money and ultimately the housing development money, because they're not having to pay for all that rock to be crushed and hauled in.
We're in what they call the Bridgeport Village here in Tualatin, and it was once an old quarry site. And up until about 5-6 years ago, where we're standing was a hole about 80 to 90 feet deep.
Engineers overcame many obstacles when they built the foundation for this high-end retail center on 28 acres in Oregon.
These are pictures of the site prior to any construction. This is actually the bottom of the pit floor over here. A lot of construction debris, asphalt, big chunks of concrete.
They constructed soil cement slabs beneath each of the building locations.
A key is compaction, because you need to compact it to get to firm it up. And then it hydrates out and solidifies, and you form a very strong, rigid layer.
And we ended up with 5 feet of the cement-treated soil that actually the buildings are sitting on. So what that does in terms of foundations, if something settles, it settles uniformly. So the whole building might settle a ½ an inch instead of one part of it settling a ½ an inch or an inch or whatever.
The engineered soil will continue to hydrate and gain strength over time.
It makes a foundation such as what we're standing on here right now. And so the clays around here are so susceptible to the moisture that you just can't work on it. It just starts pumping and movement, and so by stabilizing it, why, you can just keep working right along. I mean, when it rains, just put on rain gear and keep trucking.
Just one of the many reasons engineered soil is a much more preferred option than other applications.
It saves a lot of time by not having to haul out the existing material and bring in more structural fill.
What most people do wrong is they try to build the strength out of the asphalt, and you can do that, but it's an expensive process anymore. Asphalt's expensive. So we're trying to put the strength back into the material that's in the ground and then go up from there.
It's also environmentally sound, employing the 3 R's: reduce, reuse, and recycle.
And that's one of the big advantages of using cement, is once the stabilization or modification of those soils is completed, it's a permanent change.
It all adds up to versatility, speed of construction, longevity, and lower cost.
Oh, I'm sold on it. I've gone in where you couldn't even drive a 4-wheel drive across it, and I've gone through with this, and 2-3 days later you can drive trucks on it. It works real well.
As far as the future of using engineered soils, I think it's just going to continue to grow.